Okay, so let's start with our first lesson of Chapter 6. Chapter 6 is called Sequences and Series, and today we're going to deal with sequences. Well, it helps to know what a sequence is. So a sequence is a set of numbers written in a given order. The order has to be given to you, and there's always a rule with it. For instance, this is a sequence, 1, 3, 5, 7, 9, ... The ... is called an ellipse. It just implies that the pattern goes on using the same pattern that you've seen. And the rule here was just we were adding 2. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. This is another kind of sequence. Here we have 2, 4, 8, 16, 32, ... All that's standing for is our rule of multiply by 2. Each time we're multiplying by 2. So a couple of key differences here. We're talking about a finite sequence. It can end. It's a function whose domain is a set of integers, and they stop after a while. An example of this can be if you're doing a car payment and you're just paying it down. Every month, it'll stop. Now, an infinite sequence does not stop after a while. Its domain is a set of positive integers, so it will keep going on forever and ever and ever. It will always keep repeating. Now, with sequences, each number in them is called a term. In the previous one, 2, 4, 8, those are all terms. Now, we can call these terms where A is the first term, A1 is the first term, A2 is the second term, A3 is the third term, and so on. It just keeps going like that. So, sequences are functions. That's pretty important. So all the same rules that we know about functions still apply here. The only thing is you can only plug in the natural numbers. Natural numbers are 0 and the positive integers. So you can have an A0, A76, A123, but you're never going to have an A of a decimal or a negative number or any nonsense like that. Typically for our class, we're going to start at A1 as the first term. Now, a bunch of different types of stuff. We're going to focus right now on something called a recursive sequence. So the formula that allows any term of a sequence except the first to be computed by a previous term is called a recursive definition. So an example is the following. If a ball bounces half of its previous height on each bounce, and it was dropped from a starting distance of 16. Well, our first term here is the 16, and each time it's half of its previous term. So this would be its sequence. We go A1 is 16, A2 is 8, A3 is 4, A4 is 2, A5 is 1, A6 is 0.5, A7 is 0.25, so on and so forth. This would keep going forever in our example. Now we have a way to write these out. So instead of just writing out like, well, each time it's just half, we have a way of writing it. And it includes these. A1 is the first term, like we've seen. AN is going to be the next term in the sequence. And AN minus 1 is the previous term. Remember, we need a first term, like that 16 in the previous example. And then we need to know how to get each other term. So our first term was 8 in our previous example. And each bounce was half of the previous bounce. So A1 was 8. And then this would be our formula right here. Now, here's an important part. For a recursive sequence, you need both of these. Both of those have to be written for a recursive because I need to know the first place we started, and I also need to know how we're getting to the next term. Now, this is an example of a recursive sequence, and it's exactly like what's going to be in your Delta Math homework. We're given if A1 is equal to 8, and then we're told AN is equal to 3AN minus 1, then find the value of A4. This might look really confusing until you take a sec and realize, well, this is just saying one term is equal to 3 times the previous. We're just multiplying by 3. So that means that A1 is 8. They gave us that. They have to give us that. And then here's how we find the next one. A2 is 3 times the first, so it's 3 times 8, so it's 24. Well, A3 is 3 times the second term, so it's 3 times 24, so it's 72. And then A4 is 3 times the third term, so it's 3 times 72, so it's 216. And this right here would be our answer, 216. So here's a second example. Notice we're given the same bits of information. We're told what the first term is. We're told the rule from how to get from one term to the next. an minus 1 is one term, and we can get to the next one. And we're asked to find the value of A6. Well, we can do that. A1 is 7. Well, A2 is A1 plus 1, 7 plus 1, so 8. So that means that A3 is 9, A4 is 10, A5 is 11, and A6 is 12. Now I think you can see from this example that it'd be somewhat obnoxious to have to write this like, hey, what's the 57th term with recursive sequences? Because then you'd have to find 56 terms to begin with. Well, 55 because you have the first one. Well, that's why we have a different type of sequence that people would put as their first one, this here. The reason it's wrong is if I plug in 1 for n here and 1 here, well, I'm not going to get 500. I'm going to get 475. And that's a key thing that a lot of people make a mistake with. This is right. This right here. You're going to see this n minus 1 a lot. The reason why is because oftentimes we're not applying the rule that we have to the first term. We need a starting point. So here we're starting at 500 as our first term, and then each time we're just subtracting 25. And if we were to plug in 1 here, we'd get A1 is equal to 500 minus 25 times 1 minus 1. Well, it's 500 minus 25 times 0. That's 500. It works. You're going to see n minus 1 a lot in the equations we're going to take a look at. So here's one as it would appear on your homework. The first 3 terms of a sequence are given. Round to the nearest thousandth if necessary. Remember, thousandth is 3 decimal places. We're given these, and we're asked to find the 39th term. So here the rule is subtract 3 from the previous term. You could do this until you have the 39th term. You could just sit there with your phone's calculator and 163 minus 3, minus 3, minus 3, minus 3. That'd be kind of boring. Let's show a faster way. 163 is the first term. We're doing minus 3 because we're subtracting 3. And we're using n minus 1 again. So we can set up this equation. And then we can just plug it in right here. A39 is 163 minus 3 times 39 minus 1. And you plug that into a calculator, you get 49. I don't need to see your computations in this class. What I need to see is the original equation you put in. You're more than welcome to show me your computations, but I don't need to see them. Here's a second example. So the first 3 terms of sequence are given. Round to the nearest thousandth if necessary. And here we go. So each time we're multiplying the previous term by 4. Now again, you could just go times 4, times 4, times 4, times 4, times 4, and get your answer. No one's stopping you. I certainly can't. But you can also make an equation for it. So this is our equation. 7 is for the starting number. 4 is because we're multiplying by 4 each time. And we have an n minus 1 because the first term isn't multiplied by 4. You plug it in. This is what you get. 1,835,008. So here's your homework, folks. You got 2 delta math problem sets. They're really similar to the ones we just did. In fact, I just went on and did 2 example ones with you. This is a summary of this section that you're going to do in a Google form. No fancy Flipgrid or anything today. And then there's a reading check for our next section. Stay well. I'll talk at you soon.